This is a huge discovery, and we think that it's a huge discovery.
Have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever found because it's the nearest star to the Sun.
What the James Webb Telescope found that no one expected was city lights in space, 7 trillion miles from Earth. This amazing discovery has made people wonder if there is life on other planets. The telescope focused on Proxima Centauri B, which is the nearest star to Earth, and showed that it was giving off strangely bright lights. What could be making these lights on Proxima Centauri B look like city lights? Could this be a sign that there is life beyond Earth? Come with us as we look into how the James Webb Telescope found these strange things in space. Scientists and people in general have been waiting and studying for years to catch a glimpse of life outside of our solar system. Any proof that this space fantasy is true has been received with open arms. Scientists got the biggest surprise of their lives not long ago when the James Webb Space Telescope saw solid proof that there are living things in space. The James Webb Space Telescope was looking into space and sending important data back to Earth when it saw strange lights that looked like they came from the world Proxima Centauri B. These lights looked like they were lighting up a faraway city. Scientists are shocked at the thought of an alien city possibly existing on Earth. Each of them is confused because this life seems to be the one they've all been waiting for. If this turns out to be true, it means that intelligent life forms in space are running societies that are very different from what humans know, and we're just now finding out about them. When NASA engineers look at the city lights 7 trillion miles from Earth, they can't help but wonder how long those lights have been there, waiting for humans to develop the technology to see them. David Kipping, a scientist at Columbia University, says the exoplanet Proxima B is hard to understand because it has city lights. He says that because the heating patterns in this star system are different from other worlds, it is known that most rocky planets take in sunlight and give off infrared energy. Yes, but not for this world. Its infrared nature is very different from that of its star, which is called Proxima Centauri. The James Webb Space Telescope, JWST, was able to make a good study of this. It was the right tool for the job. Infrared bands are easy for the James Webb Space Telescope to pick up. The unique heat signature of Proxima B will help us learn a lot about the atmospheres of other planets, because the JWST has the most advanced infrared imaging equipment. This will be possible. Scientists hope to use the telescope to learn more about the mysteries of this planet's atmosphere. They also want to find out if it's possible to live on this extrasolar world. With its infrared sensitivity, the James Webb Telescope is ready to find out what happens at night on Proxima Centauri B. Most space cameras have trouble picking up the faintest rays of light in the vastness of space, but the JWST can see even the tiniest rays of light from space. It's the perfect tool to find out if reports of city lights on the night side of Proxima B are true. All man-made lights in the universe can be picked up by the telescope, as long as they are in a frequency range 1,000 times smaller than sunlight. The way Proxima's stellar features combine with its surface is very interesting. On the exoplanet's day side, there are many solar screens that collect the star's radiant energy. Its spectral limb also bounces light back into space. When Proxima B completes its orbit around its host star, Proxima Centauri, it will have a day-night cycle like we do here on Earth, with the sun heating up during the day and cooling down at night. It is known that the temperature of a planet changes because of what it is made of. In this case, Proxima B will have a huge difference between day and night if it doesn't have an atmosphere. If there weren't oceans and gases in the atmosphere, the day side would be as hot as a black body, and the night side would be completely dark and cold. Astronomers are keen to study how much the temperatures change to learn more about Proxima B's atmosphere. The JWST can quickly look at the planet's heat emissions and, thanks to its unrivaled infrared imaging capabilities, give us useful information about its atmosphere. It's interesting to note that the James Webb Telescope's orbit around Earth matches Proxima B's orbital period. This means that its day and night periods can be fully observed in 11.2 Earth days. Since Proxima B is likely to have an atmosphere, the next step is to study its chemistry to see if it can support life. Gases such as oxygen, water vapor, and methane are important signs that a place is habitable. If these elements are found on the planet, it could mean that it has conditions that make it habitable. But to find out, scientists need to be very careful as they record and study light rays as they pass through the planet's atmosphere. Although the JWST is very good at describing planetary atmospheres, it is not very good at finding bound oxygen, which is a key sign of life. Even with these problems, the camera can still look for other things in the atmosphere, such as ozone, which is also a sign of life. Another important thing to remember is that the James Webb Space Telescope can only look at some of the closest habitable worlds to Earth. Astronomers are looking forward to ground-based telescopes such as the Extremely Large Telescope, ELT, which will be launched in 2028 to study the atmosphere in more detail. The ELT will be able to peer more closely into the atmospheres of distant exoplanets, gathering information that will help us understand how habitable these worlds might be. But until then, the James Webb Space Telescope is still an important tool for us to use as we try to figure out what strange things happen on faraway exoplanets. Even though it has some problems, the Webb telescope could still change the way we think about exploring other planets, both now and in the future. The main goal for future space telescopes is to cut down on the bright light that comes from a planet's star host. This will help scientists see the planet's faint light reflections better. To do this, they plan to use internal masks or big external satellites that look like shields, like how you cover your eyes from the sun to see things better. Future telescopes will be able to study faint light reflections from faraway exoplanets better because host stars will give off less bright light. This will allow for a more in-depth study of their atmospheres and their ability to support life. However, there are problems with this process, such as the need to tell the difference between gases produced by living things and gases produced by natural processes such as volcanoes. Astronomers are still driven to learn more about exoplanets and to tell the difference between real signs of life and false ones. The Webb telescope's work on exoplanets gives us a glimpse of the amazing discoveries yet to come. As our exploration of space continues, we are learning more about how the world works and how we fit into it. Scientists have been looking through space for decades, but still haven't found any solid evidence of life beyond Earth. However, the search for other forms of life continues. Humans have long wondered if they are alone in the world. Today, scientists are using the James Webb Telescope to search for signs of life on other planets and hidden alien societies. This question has been around for a very long time. One popular story is that aliens are out there in the stars, waiting to be found. The search for extraterrestrial intelligence, SETI Institute, was founded in 1984 by Jill Tarter and Thomas Pearson, two American scientists, to investigate this idea. SETI is a non-profit group whose mission is to search the universe for radio messages from outer space. Radio waves are interesting because they can travel long distances without getting lost or swallowed up like some other types of radiation. Although SETI has been searching for more than 30 years, they have yet to find any such signs. Jill Tarter, however, is still hopeful and hopes that new technology will help speed up the search. She believes that new discoveries will be made if everyone in the world is allowed to join in the search for alien friends in space. NASA has also recently announced that the James Webb Space Telescope may have seen city lights from a world close to Earth. The JWST is the best way for people to learn about the universe because it is designed to find out hard-to-find details about galaxies, planets, stars, and how space formed in the beginning. With its stellar camera and filters, the telescope separates specific wavelengths of light, allowing scientists to study the chemical and physical makeup of distant celestial objects. The Webb telescope is constantly searching for tiny signs of life in the atmospheres of other worlds. This is helping us solve some of the most intriguing mysteries of the universe. One of these mysteries is the discovery that there is more mass in the universe than previously thought. This mass, hidden in very large galaxies, makes us wonder more about the shape and size of the early universe. 20 years ago, people didn't know much about the universe beyond our solar system. astronomers have now found more than 4,000 exoplanets orbiting distant stars. It shows how far our interest in technology can take us. NASA believes that these discoveries are just the tip of the iceberg when it comes to space. Scientists believe there are trillions of exoplanets out there that we haven't found yet. Scientists are still searching space, though they have been doing so for decades, hoping to find alien homes in places where humans have never been. Along the way, there have been times when hope seemed possible. When the Galileo spacecraft went to Jupiter, its spectroscopic instrument showed a unique set of wavelengths that supported the idea that plants could grow on other planets. For the first time, scientists found a biosignature, which means that there is life in the universe. This biomarker was called vegetation red edge, VRE. The VRE detects extraterrestrial life by looking closely at how light bounces off things. With the help of VRE, the James Webb Space Telescope, JWST, hopes to solve the mysteries of extraterrestrial environments by carefully mapping the orbital parameters of potentially habitable planets living in the habitable zones of their alien parent stars. Once these are found, the V can provide important clues in the search for intelligent life beyond Earth, embarking on a new journey to learn more about the secrets of the universe. As sunlight passes through the layers of the atmosphere, the atoms and molecules in these layers absorb the broken-up light, which has different wavelengths. Spectroscopic studies can be used to find out what a unique spectral pattern, like a fingerprint, means. As the absorption process continues, it is commonly thought that the Webb telescope will be able to pick up light from stars as it hits the atmosphere of a planet. Based on what we know so far, JWST could be the missing piece in the puzzle of what these worlds' atmospheres are made of. There is a lot of carbon dioxide, nitrogen, and oxygen in the atmospheres of Earth-sized planets. It's possible that life could exist on these kinds of planets, but the lack of strange chemicals could mean that there are other kinds of life and technological societies. Chlorofluorocarbons, CFCs, man-made chemicals used for refrigeration and other industrial purposes, could help scientists prove beyond doubt that there are advanced societies beyond our solar system. If JWST finds these man-made chemicals in the atmospheres of exoplanets, it will be clear that there is life beyond our solar system. This will give astronomers new opportunities to study the composition of the atmospheres of other worlds and to investigate the small chance that there are civilizations beyond the Milky Way. There are possibilities for life beyond Earth that can't be explained by biology on Earth. People usually think of temperate zones as places where life thrives, but the truth could be much harsher and more complicated. For example, extremophiles, a fascinating group of mostly bacterial organisms, challenge everything we think we know about where life can thrive. These hardy organisms can easily live and grow in conditions that humans would consider very harsh. Extremophiles can survive and thrive in places as hot as 250 degrees Fahrenheit and with a pH below 3. Their ability to live in the harshest conditions is a great example of how long life can last. For this reason, the vast size of the universe and the vast number of environments show that our search for life beyond Earth must be very broad. Planets that look like Earth and orbit stable stars like the Sun are great places to do studies. Also, thinking about other ways to explore, like exoplanets near red dwarf stars, which are very common in the universe, opens up new areas to study. Red dwarfs aren't as bright as our Sun, and are usually cooler, but they give us a chance to look into the possibility of life in a wide range of settings. Red dwarf stars live for a very long time, which gives slow, complicated evolutionary processes plenty of time to happen. The James Webb Space Telescope found a new planetary system called TRAPPIST-1, which is an important new finding. The fact that the planets in this system look a lot like Earth and might be able to support life is very interesting. Planets in the TRAPPIST-1 system that look like Earth. TRAPPIST-1 is a planetary system consisting of a faint red dwarf star and 7 Earth-like rocky planets orbiting the star. Of these 7 planets, 3 have been found to be habitable, meaning they are likely to have liquid water on their surfaces. The Earth's sun is bigger and warmer than TRAPPIST-1, but it gives off a soft light similar to what we see here on Earth. Scientists have been studying the light from this star very closely because it could help them find conditions that would make the planet TRAPPIST-1 habitable. The JWST studied the entire planetary system and concluded that the red dwarf star is 41 light-years away in the constellation Leo. Ward Howard, a NASA Sean Fellow and lead author of the study from the University of Colorado Boulder, was excited by the discovery. He said that JWST has made it possible for the first time in history to search for planets around other stars with atmospheres like ours. He also talked about how important it is to learn about exoplanet stars in order to learn about their solar systems. There are many stars in the universe, but Proxima Centauri stands out because it is only 4.25 light-years from the Sun. It's the closest star to Earth, but its light is so dim that it's hard to see at night. Because the star isn't very bright, any habitable planets orbiting it would have to be 20 times closer to Proxima Centauri than Earth is to the Sun for it to be habitable. Astronomers made an exciting discovery on 24th August 2016, when they found a planet with 1.3 times the mass of Earth in the habitable zone of Proxima Centauri. This Goldilocks zone has just the right amount of light for ice to melt into water, and perhaps even for life to develop. It is curious that Proxima B is an exoplanet orbiting its parent star, Proxima Centauri. Proxima B is only 4.6 million miles from its red dwarf star, but it is in a harsh environment that makes it difficult for life to survive. It is very close to the Sun, so strong solar winds could damage its atmosphere. Despite these problems, Proxima B gets enough sunlight to keep its temperature at Earth-like levels, which means that liquid water could form there. Scientists have also seen tidal locking on the planet, which means that one side is always in direct sunlight and the other is always in darkness. This is similar to the way the Moon and Earth are connected. Proxima Centauri gives off a faint glow, which is contrary to what most people would expect from a star this size. Despite its problems, Proxima B has some interesting prospects. If it has an atmosphere that can trap heat, liquid water could form on the surface, starting a chain of events that would make it possible for humans to live there. Life could start in the water and evolve into animals that live on land or in the air. Proxima B, on the other hand, receives only 65% of the energy of the Sun, making it unlikely that it could support life. The planet's tidal confinement also means that its temperature varies greatly, from very hot during the day to very cold at night. Being so close to Proxima Centauri makes these harsh conditions even worse. Proxima B is exposed to intense radiation, such as ultraviolet and X-rays, which can kill living things in the long term. Solar flares also send energetic particles hurtling towards the planet. Proxima B could lose its atmosphere if it doesn't have a strong magnetic field like Earth. This would make it impossible for life to survive. Realistic models show that planets like Proxima B that are locked in a tidal loop are likely to have their atmospheres rapidly stripped away, leaving volatile gases outside that freeze at night. Earth's atmosphere is renewed by volcanoes, but Proxima B doesn't have a similar way of replenishing its atmosphere. The mysteries of this extrasolar planet go beyond what we can see on the surface, suggesting that it may host advanced alien societies. Given the harsh conditions on Proxima B, it's not impossible that alien life forms, perhaps from the extremophiles group, could be hiding there. People don't know much about Proxima B's volcanoes or magnetic field strength, but there is still a small chance that life could exist in the planet's atmosphere. The presence of oceans on Proxima B greatly increases the chances of life there, and fuels our ongoing search for signs of advanced alien societies. In recent years, people have become more interested in finding alien life. This is because some think that advanced alien civilizations may have created better technology to survive Proxima B's harsh atmosphere. Some experts think that these aliens may have put up huge solar panels on the planet's day side to get energy from the star and use it to light up and warm the dark side. After Proxima Centauri B was found, scientists are in a heated race to see if the planet crosses the face of its star like we see from Earth. Scientists would be able to figure out the planet's size, mass, and density by measuring its movement. This would prove that it is made of rocks and give them useful information about the materials on its surface. Despite the difficulties in studying Proxima B, it is still important to find answers about this extrasolar planet. People will keep looking for other life forms as long as they are interested in what lies beyond our solar system. Proxima Centauri is also a problem because it flares up often, which makes it harder to study a habitable world like Proxima B. Luckily, the James Webb Space Telescope stays out of range of these flares and takes important pictures and data about the universe that will be studied on Earth. What do you think about the man-made city lights that Proxima Centauri B saw 7 trillion miles from Earth? Tell us what you think in the comments. Don't forget to share, like, and follow for more thrilling videos.